been a while that I made videos on mathematics. So we'll start the beautiful thing, mathematics again. And in this lecture series, we'll be studying a very important subject, which is partial differential equations. So if you talk about the applications of partial differential equations, they are huge. You name any field, fluid dynamics, modeling, disease modeling or financial modeling, everywhere you will, meet partial differential equations. So in this video lecture series, we'll be working on partial differential equations from the scratch, and we will try to understand all the concepts, in detail. So let us first start with the definition of partial differential equation. So we first of all will start with what is a partial derivative, right? So we know that if you have a dependent variable, right? Say z is my dependent variable, but I have more than one independent variables. Okay, say x and y are two independent variables. So you don't have a single independent variable, rather you have two independent variables x and y. Then we do not talk about the ordinary derivatives. In this case, we don't talk about ordinary derivatives. We talk about partial derivatives like curly z by curly x and curly z by curly y. Okay. So these are the partial derivatives, and then an equation which contains the independent variables, an equation which contains independent variables. So what are our independent variables here? So we have x, y, they are our independent variables. Then dependent variable, they can be more than one, but for simplicity we are starting with only one variable, that is z, and the partial derivatives. For example, in this case the derivatives are curly z by curly x and curly z by curly y. Something like this, an equation of this form is called a partial differential equation. Here you are only considering first order derivatives. So let us first focus on first order partial differential equation. So this is our first order partial differential equation. Okay. Sometimes we introduce this notation that we call this curly z by curly x, which denotes the partial derivative of the variable z with respect to the independent variable y. We call it as p, and then curly z by curly y, we call it as q. Then this equation becomes f x comma y comma z comma p comma q equal to 0. So this is our partial differential equation. We will use the short form PDE of first order, right? For example, you can have any example. I can have x p plus y q is equal to 2z. So this is a differential equation of this form, curly z by curly x, y curly z by curly y equal to 2z. So an equation of this form is going to be called as a partial differential equation. Now let us see what do we mean by the solution of the partial differential equation. Because we are interested in this course, we are interested in solving the partial differential equation. So let us see what do we mean by solution of PDE. Okay, so we want to see what do we mean by solution of partial differential equation. So we say that suppose you have this x and then you have y, right, and suppose you have omega is the domain, some domain, right, because when we talk about the solution of the partial differential equation, we'll be talking about some domain, right. So suppose omega is the domain of the a domain where we are seeking to have the solution of the partial differential equation, right? So we are going to say that if we are looking for the solution of the partial differential equation f x y z p q equal to 0 in the domain omega, okay, for some domain omega, omega is a subset of R2 because it is in xy plane. The solution is a function because solution is going to be a surface. The solution is a function z equal to f of x comma y. It will be some surface maybe here. F of z is equal to f of x comma y such that first of all it has to be defined in omega. It has to be defined in omega. Okay, so you see these things should be very clear to everybody. I have seen that students later on they struggle with these understandings, right? Second thing, what is important, because we are talking about the partial derivatives of z, so it has to be a function in the space C1. What is C1? C1 is a space of functions having continuous first order derivatives, first order partial derivatives in this case, partial derivatives. Okay, then only this function will be eligible to be a solution. This is very important. This will make your understanding very strong regarding the differential equation. And then the third point, we want that for every x comma y in omega, this point x comma y comma z, z is coming from here, comma p comma q should be in the domain of, should be in the domain of capital F. Capital F is representing our PDE because xy will come from the domain here, and then z will come from the solution, and then p and q will also come from this solution. So this point x comma y comma z comma p comma q has to be in the domain of f. So you can think of f as a function from say R5 because it has 5 inputs, right? And then the fourth point is when z equal to f x comma y is substituted into our equation, let us call it as star, is substituted in star, that is f of x comma y comma z comma p comma q equal to 0, okay, it should reduce, it should reduce to identity, right, for all x and y in omega. If this happens, then we say that this particular function is our solution of this particular partial differential equation. Okay, so this is very important. Let me give you an example. So example you can look at here, that you have a differential equation. Consider the PDE PQ equal to Z. This is your PDE, right? And I say that Z equal to x into y is a solution of star in R2. See? So first of all, can you see that this this is defined in R2? Defined in R2, and also this is in C1 because both the partial derivatives with respect to x as well as with respect to y, they exist in R2, right? And then for any x comma y, if I take z which is xy and then the partial derivatives, this will be y, this will be x. This is in the domain of this function because this function is pq minus z equal to 0. There is no problem in the domain. Is in the domain of f, right? And then also I can see that this is the most important point, that when I put this z here, so when I put this z here, this is actually pq equal to z. So that means curly z by curly x into curly z by curly y is equal to z. Now I substitute this z here. So what I will get? I'll get curly by curly x of xy, curly by curly y of xy equal to z. So that will be this will be y into x equal to z is xy. So which is identity for all xy in R. Okay, so that means this is a solution. This is a solution of this PDE. Generally, we when we actually will see that we'll progress in this course, we are not going to check these conditions. We'll straight away just verify this. But back in your mind, it should be clear that these things are equally important, right? Otherwise, things will not make sense. Okay, so thank you, students. Please share this video and subscribe to this channel and keep supporting. If you have any doubts, please write in the comment box. Happy learning. Bye.